Hello and welcome back to this course, covering the exam topics for the JNCIS-SP certification. In this section of the course, we're reviewing Layer 2 switching and VLANs, where we're covering Layer 2 switching mechanisms and Ethernet switching configurations in Junos. In this video, we'll be covering frame processing. You may recall from your studies in the JNCIA Junos that the packet forwarding engine is programmed by the routing engine and is mostly responsible for forwarding transit traffic. In this video, we'll be reviewing the processing workflow used by the switch to handle three classifications of traffic: unknown source, known destination, and unknown destination. Understanding how a switch handles different types of traffic can help build the scaffolding to understand the configuration features we'll cover later in this course. First, let's do a quick review of the Junos architecture. Just like other Junos devices, EX series switches feature a distinct control plane and forwarding plane: the routing engine and the packet forwarding engine. The routing engine derives the forwarding table from the routing table that it builds from protocol information that is passed to it by the PFE. The FT, or forwarding table, is then programmed into the PFE and used to forward transit traffic. Something to note is that the link here between the PFE and RE is rate limited and hard coded so that it cannot be modified by the network administrator. This protects the RE from being overloaded and ensures device stability. However, it does potentially open an attack surface for a denial of service attack on the device by saturating the link with exception traffic. So, now that we've reviewed the RE and PFE relationship, it's time to expand on that by considering how the EX switch responds to the three types of traffic we identified earlier: unknown source, known destination, and unknown destination. Especially considering that we could potentially have a large modular chassis switch with many PFEs, as a PFE represents a line card and multiple routing engines potentially. First, let's take a look at unknown source. The first step in our workflow is to receive the frame, ingress, on a port on the PFE. The ingress PFE then performs a MAC lookup on the source MAC address and finds out that this source MAC address is not yet known. There is not an entry in the bridging table for this MAC yet. The ingress PFE sends the header information to the RE, where the MAC is added to the bridging table if it is able to within the parameters of any Layer 2 security protocols like MAC limiting. If the RE is able to add the entry to the bridging table, the update is then programmed onto the other PFEs on the device. As we see in the flow diagram, the frame comes in, source is looked up by the ingress PFE 0, header is transmitted to the RE, and the new bridging table entry is then communicated to all PFEs in the chassis. Now, let's take a look at what happens when the source and destination are known. In this flow, we see the same first step, that the frame is received ingress on a port on PFE 0. PFE 0 performs a lookup and determines the egress PFE and port to reach the destination MAC address. The frame is forwarded to the egress PFE and then forwarded out the egress port. This is transit traffic. Transit traffic is never seen by the routing engine, as the PFE has all the information it needs already to successfully forward the frame. Finally, let's take a look at what happens when the destination is not known. When the frame is received and the ingress PFE performs a lookup in the bridging table and doesn't find an entry for the destination, the flooding mechanism is used to ensure the frame is successfully forwarded to its destination. The ingress PFE forwards the frame to all PFEs in the switch so that it may be flooded out all ports within the broadcast domain. Note that in this case as well, that the routing engine is not made aware of the frame when the destination is not known, except for statistical counters that it may read on the PFEs, indicating how often this situation occurs. I appreciate you working through this lesson with me. I hope that this lesson has been informative for you, and I would like to thank you for viewing.